Imagine a world where your refrigerator, air conditioner, or even the cooling systems in supermarkets no longer rely on gas, Freon, or any chemical refrigerants at all. What if the way we keep our food fresh and our homes comfortable could be completely transformed, making traditional cooling methods a thing of the past? Picture a future where cooling is not only quieter and cleaner, but also dramatically more energy efficient. Instead of noisy compressors and harmful chemicals, imagine using only solid materials and the power of magnets to keep things cold. This isn't just a fantasy. This technology, known as magnetic cooling, already exists and is being tested in labs around the world. But if this breakthrough is real, why don't we see it in our local grocery stores or public markets? Why are we still relying on old, energy-hungry systems? Welcome back to GAIUS, where we dig into the science and the stories behind the tech that could change our lives. Today, we're exploring the world of magnetic cooling, a real working technology that sounds revolutionary, but for some reason hasn't made its way into our everyday appliances or commercial spaces just yet. In this video, we'll break down not just how magnetic cooling works, but also what makes it so different from the systems we use now. We'll look at the science, the engineering, and the potential impact on our environment and energy bills. But we'll also tackle the tough questions. Why isn't this technology already in public markets and supermarkets? What are the real barriers, technical, economic, or otherwise, that are holding it back from widespread adoption? And where does magnetic cooling actually make sense to use? Are there places or situations where it simply isn't practical, or where traditional cooling still has the upper hand? Finally, we'll ask, is this technology destined only for wealthy countries and high-end homes, or could it eventually help bring reliable, sustainable cooling to developing regions as well? Let's find out together. Magnetic cooling is based on a fascinating scientific principle known as the Magnetocaloric Effect. This effect is observed in certain solid materials, often special metals or alloys, which react in a unique way when exposed to a magnetic field. When a magnetic field is applied to these materials, their internal structure changes, causing them to heat up. But when the magnetic field is removed, the material cools down rapidly. This temperature change can be harnessed to move heat from one place to another. By carefully repeating this process in a controlled cycle, engineers can transfer heat efficiently, much like how a traditional refrigerator works. But here's the key difference. Magnetic cooling systems don't need refrigerant gases or bulky compressors to operate. That means no Freon, no risk of greenhouse gas leakage, and no reliance on the traditional vapor compression system that's been used for decades. This makes magnetic cooling a much more environmentally friendly option. And this isn't just a theoretical concept. There are already working prototypes in research labs, real-world evaluations underway, and innovative companies actively developing magnetic cooling technology for commercial use. But here's the important part. Just because a technology works in the lab doesn't mean it's ready for mass adoption. Challenges like cost, scalability, and efficiency still need to be addressed before magnetic cooling can replace conventional systems everywhere. Magnetic cooling offers several real advantages: higher theoretical energy efficiency, much quieter operation, fewer mechanical components, and no harmful refrigerants. That's why many videos call it the future of refrigeration. But this is where many explanations stop, and where reality actually begins. Let's be very clear. Magnetic cooling is not ideal for homes right now, and it is not a direct replacement for household air conditioners. Why? Because it works best in constant, stable cooling environments. It's not designed for frequent on-off cycles, and control systems are more complex than standard compressors. Where magnetic cooling does make sense: supermarkets, cold storage facilities, industrial refrigeration, data centers, and medical and research facilities. So when you hear claims like this will replace your home aircon soon, that's not realistic. This is the question most creators don't answer, but it's one that's crucial to understanding the future of refrigeration technology. If magnetic cooling is so efficient, clean, and quiet, why don't we see it everywhere, from wet markets and fish ports to public refrigeration hubs and supermarkets? The technology sounds like a game changer, so what's holding it back from becoming mainstream? Let's break down the real reasons. First, there's the high initial cost. Magnetic cooling systems require specialized materials and advanced engineering, which means the upfront price tag is much higher than traditional refrigeration units. The rare earth magnets and precision components used in these systems are still expensive, especially since the industry hasn't yet reached the scale needed for mass production. Without economies of scale, prices stay high, making it hard for small businesses to justify the switch. Then there's the lack of a maintenance ecosystem. Unlike conventional fridges, there aren't many technicians trained to repair or maintain magnetic cooling systems. There's no widespread technician training, and local supply chains for spare parts and repairs simply don't exist yet. If something breaks, getting it fixed can be a major headache, especially in remote or busy market areas. Another big factor is risk aversion. For many market vendors and operators, reliability is everything. They're used to equipment that's been proven over decades, and new technology feels risky. Most vendors prefer to stick with what they know works, even if it's less efficient. The fear of downtime or unexpected failures with unfamiliar tech is a real concern. For small business owners, every day without refrigeration is a day of lost income. They simply can't afford to experiment with systems that might not deliver. And finally, there's the reality of return on investment. Even if magnetic cooling promises lower electricity bills, the time it takes to recover the initial investment can be years. For many businesses, especially in developing markets, the priority is immediate cash flow, not long-term savings. The upfront cost is just too much of a barrier. So, while magnetic cooling has huge potential, it faces real-world challenges: high costs, lack of support infrastructure, risk aversion, and tough financial realities. Until these barriers are addressed, don't expect to see magnetic cooling in every market just yet. Short answer? Right now, yes, mostly. Magnetic cooling currently favors developed countries because it relies on advanced materials, manufacturing is complex, infrastructure is more stable, and governments often fund pilot projects. But this doesn't mean developing countries will be excluded forever. Possible future paths include cheaper magnet materials, simplified system designs, shared cooling hubs instead of individual units, and government or cooperative-owned cold storage facilities. This technology isn't an overnight revolution. It's a long-term transition. A realistic timeline looks like this: 5 to 10 years for wider industrial and commercial use, 10 to 15 years for limited public market adoption and residential homes. Well, they're the last priority. Magnetic cooling is real. It's not hype, but it's also not a miracle solution. It will complement existing systems, not instantly replace them. If you want future technology explained without exaggeration, with real-world context and honest limitations, subscribe to GAIUS. And let me ask you this: if you were a market vendor or business owner, would you risk switching to a new cooling technology? Why or why not? Let me know in the comments.